Welcome to our presentation. We are Group 3 and I am Mahendran Sukumar and we are presenting the induction cooker as our invention of choice. We have to ask, what is an induction cooker? An induction cooker heats a cooking vessel by electrical induction, and instead of using a flame and using thermal conduction to heat up a wok or a pan, we use an electrical heating element which creates a magnetic field in which creates the heat in the pan which cooks the food. And the pan which is used in the induction cooker must be made of or must contain a ferromagnetic metal. And the image on the right shows you the common composition of an induction cooktop. And if we are looking at the detail, the induction stovetop commonly consists of aluminium plates or aluminium stampings, ferrites, insulated gate bipolar transistors known as IGBT, central processing unit which handle the sensors and handles the control panel, and also the inductors or the burners. So let's look at the history of invention. Looking at the history of the induction cooker, patents date back as far as 1900s, the early 1900s, and the first induction stove, however, was manufactured at the beginning of 1970 in America by the Westinghouse Electric Corporation, and precisely the Research and Development Division. And in 1971, it was put on the public display in Texas. And these units were named the Cool Top Induction Range, and they had an entire range of induction cooktop with a single heating element on the surface. And the next series was also developed by the same center in the Westinghouse Electric Corporation and was suggested Cool Top 2. A single burner induction cooktop was offered for $1,500 and it was made up of a quadruple and four heating elements of each providing 1,600 volts. The first induction cooktops with four burners were sold on the market in the middle of 1980 by Sears, a manufacturer of household appliances. These stoves were provided with low power, limited resistance, and there was also some problems with the noise they produced. But in the next years, both American manufacturers like Cooktech and Luxeen and European and Asian manufacturers continued to improve the appliances based on induction technology. But in the next years, in the coming years, the popular brand Panasonic manufactured an entirely metal induction burner, which could be used with non-ferrous metal vessels. But because of that feature, the aspect of the heat produced by the induction cooker was lower and it was less efficient. Okay, now let's look at how the induction cooker functions. The main principle used is electromagnetic induction, which is the movement of magnets around the coil of wire, which then creates an electrical current through the wire. This is done by rotating magnets while a coil of wire moves in between them. The magnets will rotate between north and south poles, and if the both same poles of both magnets meet, they will push together, and if both opposite poles meet, they would pull. And this produces a push and pull which causes the magnets to rotate around the coil of wire, thus producing an electrical current. And induction cooktops only creates heat inside the cookware and needs a special type of cookware to function. If we put certain materials into a rapidly alternating magnetic field, the material absorbs energy and heats up. That's because the field creates electrical currents inside the material, and the resistance of the material converts this electrical energy into heat. And this heat is then transferred to the food inside the pan, which is what that cooks it. In every induction cooktop, there is usually a tight spiral of cables made of copper. The cooktop controller pushes an alternating current through this coil, which changes direction about 20 to 30 times per second. And this current flow is what creates a magnetic field above the coil. And as the current alternates back and forth, the magnetic field also alternates back and forth. And by putting a ferromagnetic pan or ferromagnetic cookware on the stovetop, the magnetic field induces eddy currents or electrical currents in the metal base of the pan. And by the resistance of the pan itself, those eddy currents resist the flow and thus acts like an electrical heater which creates heat and which is conducted into the food which cooks the food. Another principle that the induction cooker uses is the magnetic hysteresis loss. Small patches of similarly aligned dipoles within the magnetic field, called domains, resist the applied field and are responsible for the lag. Hysteresis losses is known as the power dissipated, and it is a result of the domains resisting the breaking and building of the field. Therefore, heat is released when the domain's walls are set in motion by the applied magnetic field, and this heat is a very important part of induction cooking. Among both principles, the importance of the Joule heating and the importance of magnetic hysteresis laws are both very important, but which is more important is still unknown.
How does this device even work, and what's the physics that goes on behind it? Well, I'm here to explain exactly that. The main concepts of electromagnetism that we are going to see is electromagnetic induction and also eddy currents. So, what exactly are they? Well, electromagnetic induction is based on Faraday's law of electromagnetic induction. It is basically an electromotive force that is produced across a conductor when there is a changing magnetic field present. Faraday's law is a basic law of electromagnetism, predicting how a magnetic field will interact with the electric circuit to produce an EMF or electromotive force. And this is a phenomenon known as electromotive or electromagnetic induction. The direction of the induced field can then be described by Lenz's law, which states that the change is opposite to the induced current. So the mathematical equation that we use to describe this is described as epsilon equals negative n d phi over dt, where epsilon is the induced voltage, n is the number of loops, d phi is the change in magnetic flux, and dt is the change in time. Now, the negative convention in this equation is needed to show that the induced voltage is opposing the change in flux that causes it, as it was described by Lenz's law. So this is the first concept, that is electromagnetic induction. So moving on to the second concept, which is eddy current. So let's look at eddy current. Eddy currents are electrical currents induced within conductors by a changing magnetic field in the conductor. So when we see, according to Lenz's law, an eddy current creates a magnetic field that opposes the change in the magnetic field that created it. So the magnitude of this current is actually proportional to the strength of the magnetic field, the area of the loop, and also the rate of change of flux. And it is inversely proportional to the resistivity of the material or resistivity of the conductor. So now, after we know that what are the two main concepts in this induction cooker device, it comes to how does this device actually work. So the working of the device is very simple, and it can be simplified to four main steps. So how does this device work? Firstly, AC current flows through the copper coil in the induction cooker when the power is switched on. This results in an oscillating magnetic field produced that will in turn induce a magnetic flux. So this magnetic flux causes an electrical current, or also known as the eddy current, to be induced in the metal pan. So this large eddy current flowing through the resistance of the metal pan will result in resistive heating, and this resistive heating will cause the metal pan itself to heat up. So when the metal pan heats up, thus this allows the food or liquid or whatever that is in the metal pan to also be heated up and cooked. So this is how the induction cooker functions, and this is how it applies the two main concepts of electromagnetism, which is electromagnetic induction and also the concept of eddy currents.
Hello everyone, my name is Harish Osana from Adinarena. So we can see the schematics diagram of the device here. So first of all, let me show you the system overview. In the system where we can see induction coil, a flat cable that connects the power board, and the control board is installed in it. So in this prototype, we can explain that in the induction coil, when the current flows inside, it causes a magnetic flux, which then induces current in the pan, and later it causes the pan to heat up. And when it comes to power board, the power board is responsible in converting the AC input into a 310 volt by the bridge rectifier over here, which is later converted into a magnetic field that is used for cooking by the LC resonator over here. And also for the control board is responsible for some extra features which is provided by our induction cooker, such as setting up the temperature and more, and detecting and measuring noise, temperature, voltage, current, and it also responsible for driving the cooling fan and buzzer. Other than that, why do we think the induction cooking is more effective than any other cooking? Is because basically it is faster than any other cooking method. Induction they send more energy rapidly into the pan than a gas burner and electric also, which results in a much better, more time saving compared to other methods. And the immediate response with all the energy that going directly into the pan and no grate, coil or Rayleigh burner to heat up, the temperature can be raised or lowered virtually instantly. And induction cooker also energy efficient because there is no energy wasted by heating up the surrounding air. All the energy is directly transferred to the pan only. And we can also control the temperatures by without having any trouble because we have the digital controls on the induction cooker, so we can precisely set the temperature, and it also has a wider temperature range, so induction cooktops offer a higher boiling point and a lower simmer temperatures than gas and hold them steady. And induction cookers are also basically safer than any other cooking methods because they have little to no flame, and the residual heat is also minimized, so it reduces the chances of getting accidental burns. And it also keeps our kitchen cooler. So since virtually all the energy is going into the pan rather than the air, the kitchen stays cool all the time, and the induction cooktop is also easier for us to clean as it is made of ceramic glass surface with no hot burner grain and which food can bake, and also there is no spots where grease and food bits can accumulate, so it's easier for us to clean it later. And also the cooking can be made evenly, as when it comes to gas flame or electrical radiator coil, only one part is heated up most of the time, which is the middle part obviously. But when it comes to induction stove, all the parts are heated up simultaneously and more evenly compared to other burning methods. And here we can see a graph to show the difference between induction and electrical coil. So based on what we can see, the induction cooker, it takes lesser time compared to an electrical coil to heat up 2 cups of water. As you can see, the induction cooker, it took around 5 minutes to boil the cup of water compared to the electrical coil, which took around 8 minutes. So induction cooker obviously takes lesser time than an electrical coil, and also gets off to a faster start compared to the electrical coil. Electrical coil took around 1 minute to get heated up, while induction cooker, it took no time to heat up, as it got instantly heated up to 100 degrees Fahrenheit before even 1 minute. So this is because there is no energy is wasted by heating up the surrounding air around the cooker, as all the heat is directly transferred to the pan, and there is no heat transfer between the pan and the flame. Between the flame and the pan, which will result in a lot of energy being wasted by heating up the surrounding air also. So that's all from me. Thank you.
Hi, I'm Kuhan Raj, and I will be talking about the advantages and disadvantages of induction cooker. Throughout the development in technology, induction cooker is getting advanced too. Lately, we can find an impressive diversity of induction unit solutions on the market, such as improved in designs and prices become more accessible. Now, we will see the pros and cons of induction cooker. As mentioned, induction cooker is a replacement of traditional cooking which uses gas and flame. The first advantage is induction cooker is faster. A traditional cooker generates heat energy some distance from the cooking pot or pan and attempts to transport as much of that energy into the food. Induction cooker sends more energy rapidly into the pan compared to a gas burner, which makes the cooking faster. Secondly, induction cooker has more energy efficient compared to other cooktop. With induction cooking, the heat is produced in the pan instead of cooktop, and much more energy goes into the food. No energy is wasted heating the air around the pan. Induction cooking has about 85% energy efficient compared to 74% for an electric cooktop and 40% for gas cooktop. Next, induction cooker is installed with precise temperature control, which allows the user to go from high to low heat instantly. Induction cookers are usually built into ceramic or glass cooktops, which always remain cold as only the vessel gets hot, hence very easy to keep clean. Furthermore, induction cooker is a lot safer than traditional cooking. Since induction cooker is using magnetic field, then there is no open flame and no heat to burn us or a gas leak. Heat appears only when cooking pan is in place. Furthermore, induction cooktops are equipped with special sensors that will automatically shut them off when there is no pan on the hob. Combustion-type cooking makes significant amounts of indoor air pollution. For example, gas stoves generate nitrogen oxide, which commonly associated with diesel engines. Although electric cooking can still give some unhealthy fine particles of air pollution, especially when frying, it's generally cleaner and better for health. Now, for the drawbacks or disadvantages of induction cooking is it is a bit costly. Induction cooker could be 2 or 3 times more expensive than an ordinary electric or gas cooktop. Although the prices are getting slightly cheaper due to many companies are using this product, but the cost to maintain this induction cooktop is expensive. Moreover, the cookware should be a ferromagnetic material or the base should be covered with iron. Non-ferromagnetic materials such as copper, aluminum and glass will not work. This because only a ferromagnetic material efficiently produces eddy currents and heat from magnetic fields. Another minor disadvantage is that induction cooker makes low noise due to built-in cooling fans and produce low radio frequency like microwave, which can affect people who wear heart pacemaker, but it does not pose a risk. The radiation diminishes to nothing at distances of a few inches to about a foot. The main disadvantage would be is that if the power goes out or cut off, the induction cooker cannot be used since it needs electric current for induction. For the limitation, the induction cooktop requires different voltage to function. Almost all induction cooktops today are made to be compatible with the common standard voltage supply. A single burner induction cooktop required minimum circuit would be 15 amps. A cooktop with 4 to 5 burners has a minimum circuit requirement of 40 to 50 amps. So these are the advantages and disadvantages of induction cooktop. Thank you.
Okay, so therefore, as a conclusion, we shall look at the current applications of induction cooktops and its future plans. So therefore, with the increase of induction cooktops in the culinary field, chefs have to get used to the efficiency and the speed that the pan heats are very fast. Chefs also need a little knowledge of the workings of induction cooktops and the pan's construction in order to cook properly. And chefs need to use pans made with ferrous materials so that heat is conducted efficiently. Therefore, there is a little bit of different education for the chef and extra education for them to function properly. And this goes the same for house cooks. And as for future plans, some companies have researched the use of induction in catering, where an induction house is put underneath a sheet of granite, and the current is sent through the granite to the chafing dish to keep it warm. This might change cooking and catering as stovetops and cooktops may cease to exist, with cooking integrated directly into the kitchen slab. Therefore, that's it. That's it for our presentation as Group 3, and thank you for watching. And these are the references that we used throughout our presentation and throughout the preparation of our presentation.